Okay, so today's lesson we're just using the sine rule to find angles. So the thing to remember with the sine rule is we can flip it upside down. So you remember in the last lesson where we've got the sine rule down here, it had, instead of having sine A over A and sine B over B, it had A over sine A and B over sine B. So you can choose to flip it around to best suit you. What you're generally trying to do is get the thing that you want to find out in that top left-hand corner. So that whatever goes there is the thing you're trying to find out. So if we have a look at the first question, I think it's probably just easier to jump into some examples. Much like yesterday, we're looking for angles and their opposite side. And in this particular case here, we've got this side here is opposite to this angle, which we don't know, but we do know 3 of the 4 things we have in the formula. So if there's only one thing we have left out, then we'll be able to work it out. So we want that in that form of sine A on A equals sine B on B. Then I'll actually start putting in what I know from this triangle. So I know that the angle is called theta, so sine theta on 4.43 equals the sine of 106, it's a terrible 106 degrees and 49 minutes over the side that's opposite to that one, so 9.17. So once again, just as we did with the last lesson, we pair up our opposite sides and our angles together. And much like yesterday, we want to get rid of this denominator. So if I multiply this side here by 4.43, then those two are going to cancel each other out. I'm going to be left with just sine theta. But obviously, whatever I do to one side, I've got to do to the other. So I'll have to multiply that by 4.43. So we're going to end up with now sine theta equals sine of 106 degrees 49 minutes over 9.17 times by 4.43. And at this point, I pull out my calculator and I'll plug that into my calculator. So we've got a fraction, and up the top we've got sine of 106 degrees 49 minutes. Remember to press the degrees, minutes, seconds button after minutes as well. And it's over 9.17. And that's multiplied by 4.43. And at this point, I'll be encouraging you to write down the first few digits of that into your calculator. So what's that? 4624, sorry, onto your page, 4624. So I'm going to say it equals 0.4624, and then I just leave myself a few dots. That's to tell the reader that I know there's more there on the calculator. I'm just giving you a basic summary of what's there. I'm not rounding, it's not the end. I'm not getting rid of that thing that's in the calculator. And to find what theta equals, obviously, just like in normal trig, I'd need to do sine to the minus 1 of 0.4624 ... Now, I'll do that by using the answer key in the calculator. So I'll go shift sine, and then I'll press answer. And that way I'll get the exact answer out of the calculator, not some abbreviation that I've written down. So that's going to wind me up with 26.54. Now I'm just going to check the question. The question asks me to get the answer to the nearest minute. So I better press the degrees, minutes, seconds button. 27 degrees, 32 minutes, 40 seconds. So 27 degrees, 33 minutes. Okay. We'll move on to the next one. Now the next one is a common way that maths teachers like to confuse you. Once again, we want to look for the angles on opposite sides. This one, we're after angle BAC. So angle BAC is this angle in here. So that's its opposite side. Okay. And then I've got this angle in here is the only other angle I know anything about. So I care about its opposite side. So they're the angles and opposite sides I care about. This piece of information here is there just to confuse me. I don't want it. All right. I've got to be confident enough in my process to know that I don't need that piece of information. So once again, we write the sine rule out, sine A over A, and I'm doing it with sine on top because I want to find an angle, not a side, equals sine B on B. So if I substitute in this particular case, I think I'll just call that angle A anyway because it's angle BAC, it's the angle at A. And that's going to be over 4.2, and then equals sine B, which is sine of 100, and that's going to be over 8. Now, once again, we've kept our angles and opposite sides together. And once again, we want to get rid of this denominator, so we're going to multiply this side by 4.2. That'll cancel that out nicely, but I'll have to do that to both sides. So I'm going to end up with sine of A equals the sine of 100 over 8 times by 4.2. All right, so once again, we put that into our calculator. So sine of 100 over 8 times by 4.2 is going to give me some number, 0.517. 17 dot dot dot. So therefore A is going to equal sine to the minus 1 of 0.517. And once again, get in the habit of using that answer key in your calculator. So shift sine, then press answer, and that's going to give me my exact answer there. So in this particular one, I need it to 1 decimal place. So that's going to be 31.1 degrees. Okay. Now I'm going to skip the next question because I want to spend a little bit of time on the last one. So have a go at that one yourself. I'll put some notes on OneNote so you can see what the correct answer is. But I want you to move on now to what we call the ambiguous case. Now this happens with the sine rule because we, unlike when we use SOHCAHTOA, we can have angles in a non-right angle triangle. We can have angles bigger than 90 degrees. And if you remember, for every angle, every acute angle, there's a matching obtuse angle that has the exact same result. And so your calculator is only going to tell you what the acute angle is, and we have to know how to find the obtuse angle. So just to run through some basic ideas here. So if I did the sine of 60 degrees, I would get 0.866. And if I did the sine of 120 degrees, I would also get 0.866. And the reason why they're the same is that the sine of is that 60 and 120 both add up to 180. So anytime the two angles add up to 180, we're going to have the same ratio. So here we've got sine 40 and sine of 140. This will do the exact same thing. So the sine of 40 is 0.643. And the sine of 140 should be exactly the same, 0.643. Okay, and now I just happen to know, because I paid attention when we did the exact ratios question, that this is going to be 0.5, and therefore sine of 150 should also be that, should also be 0.5. So let's see if that's right, and it is. Okay, so going back the other way, if we calculate theta for both the acute and the obtuse cases, if I have sine of 0.3, so I would put sine theta equals 0.3, so shift sine of 0.3 is going to give me the angle. So that's 17.4, we'll call that 17.5 degrees. So therefore, the obtuse angle is going to be 180 degrees minus 17.5 degrees. So if I go 180 minus answer, I'm going to get 162.5. And let's just check that out. If we do the sine of 162.5, obviously it's not going to be exactly the same because I've simplified it a little bit. We end up very close to 0.3, which should be only in the rounding that it's any different. Okay, I'll quickly do the next one and we'll probably skip the one afterwards. So if we go shift sine of 0.67, we're going to end up with 42 degrees. So the obtuse angle is going to be 180 minus 42 degrees. That's going to be 138 degrees. Okay, and the same process applies there for the last example. But I just want to leave us time to move on to this one. So in this particular example, you guys only generally have to worry about obtuse angles if you get told there's an obtuse angle, or if it's obvious there's an obtuse angle. Okay, so yeah, look for that as a clue, but it shouldn't be all that well hidden. So nonetheless, we're still doing our rule the exact same way. We're looking for an angle and its opposite side, and we're looking for another angle and it's, another angle there and its opposite side, and that's the angle we're trying to find. Angle BAC is the angle we want to find. So we still do the same process all the way through from the start. So we're going to go sine A on A equals sine B on B. There's our formula. Now we'll substitute in what's in our particular question. So the thing that we want goes in the top left-hand corner. That's that angle, and we're going to call that angle A because it's at the point A. So we'll leave that alone. Over 12 equals sine of 21 degrees over its opposite side, which is 8.2. Always remembering to keep the thing that we don't know in that top left-hand corner. So if we multiply this by 12, that'll get rid of that denominator and simplify things as well. So we'll need to do that to both sides. So our next line is going to look like sine A equals sine 21 degrees on 8.2 times by 12. And now at this point I can pull out my calculator and work that out. So I'm going to have sine 21 degrees over 8.2 multiplied by 12. And that's going to give me 0.524. So A is going to equal sine to the minus 1 of 0.524 dot dot dot. And that's going to be, so we go shift sine of the answer. Try to use that method. I'm going to get 31.63. Now what does it say in here? To the nearest degree. So in this particular case it's 32 degrees to the nearest degree. And then we can say, but angle BAC is obtuse, because that says so in the question. We highlighted that up there in yellow. So we have, therefore, angle BAC equals 180 minus 32 degrees. So in this particular case, that's going to be 148 degrees. And that's how that is done.